Lesson 3, using reasoning to find a counterexample. So a counterexample basically proves your conjecture wrong. So if I made the conjecture, all students in grade 11 can drive. Is that reasonable? Is that right? Can you come up with a counterexample? And a counterexample might be that some don't have their licenses. So the reasonable conjecture would be that people in grade 11 are the right age to drive. So they might not have their license, but they are the right age to drive. So our counterexample would be any student you know that doesn't have their license who's from grade 11. And there's probably lots of them. I can think of a couple off the top of my head, but we're not going to name names, but you can on your sheet. Go right ahead. Okay, so Miss Douglas makes a conjecture that the difference between consecutive squares will be prime. Is this a reasonable conjecture? If it isn't, provide a counterexample. So we did this one in the last one. So number, square, difference. So if we do 1, 2, 3, 4, 5. So we have 1 squared is 1, 2 squared is 4, 9, 16. I don't know what I was going for there. And 25. 4 minus 1 is 3, which is prime. 9 minus 4 is 5, also prime. 16 minus 9 is 7, prime. 25 minus 16 is 9, not prime. So this would be a counterexample to Miss Douglas's conjecture, which is me. So to fix this, we could fix the conjecture by saying that the difference would be odd and not prime. Okay, you notice this pattern. Will the pattern continue? If not, provide a counterexample. So this is simply just trying. So if we continue the pattern on, 1, 2, 3, 4, 5 times 8 plus 5. Type this into your calculator. You should get 9, 8, 7, 6, 5. So I want you to pause the video, keep going, and if it seems to be a pattern that works forever, unpause the video. If it seems to be a pattern that stops, also unpause the video. Okay, if you kept the pattern going, you should get to this point and it should work. But the problem now is, what do you do when it's 10, when it's a 2-digit number? So times 10, 8 plus 10, it doesn't work. You don't get the right answer. You get, I don't even know what you get because you can't even type it into your calculator, but it does not work because when you add the 10, it completely screws up the pattern. So that counterexample, once you get to 10, is your counterexample. So this, if we were to fix our conjecture, we can say that this pattern continues 1 through 9.